Okay, so we're looking at how to solve systems algebraically now. So the last 2 days have been graphically. Now we're going to do algebraically, which means we're going to basically use math equations and we're going to solve for variables instead of graphing and looking for the cross. So learning target, I can solve a system of linear equations by using the substitution method, and then I can do the same thing using the elimination method. Okay, so we're going to do both of those today. And eventually you'll be able to choose which one you want. I mean, it's not, for right now we're just going to say use this way, use that way. I want to know you can do both. And then after that, it's really up to you which way you use. So when should we use the substitution method? Well, the substitution method is great for when a variable is already solved for. And what we mean by that is if you look down here, like here, y is by itself. And in both cases, it's by itself, but really just need one of them. If one of them, the y is by themselves or the x is by themselves, this is perfect for substitution. If you remember, what we're going to do is, and it doesn't matter what, this one's kind of hard to tell, I guess. But maybe we'll start with this one. I've got q by itself, so I'm going to take the other equation. Where q is, I'm going to leave a space. So 4p plus 2, I'm going to leave a space, equals 8. I'm going to take q out and put what q equals. So q got kicked out, negative 2p plus 1 got put in its place. Okay, and notice there's just p's left. Okay, there's no q's left in this equation, and I can solve for p. If there's one variable, I can get an answer for that. So here I got 4p plus, I got to distribute, so positive 2 times negative 2p would be a negative 4p. 2 times 1 is 2. That equals 8. Okay, and then on this one, I got 4p minus 4p is 0, so I got 2. 0 plus 2 equals 8. And on this one, when the variables disappear, you can't graphically see that they don't cross, because we graph them, we see there's no solution. When the variables completely disappear and this is not true, there's no solution. So I always think not true equals no solution. So think ends, not true, no solution. So going back here now, it's probably going to be an easier substitution if I use what y equals. I'm going to plug that in for this y. So here I've got y equals negative 2x plus 7. Well, that y is the same thing as x minus 2. Now, another way to look at this is when they're both y equals, just set the equations equal to each other. That's what I did, basically. So if I add 2x to both sides, I got 3x minus 2 equals 7. Okay, add 2, I got 3x equals 9. My video froze. There we go. And then divide by 3. So I got x equals 3. Now, a lot of the students think they're done now. They got an answer. But if you remember right, these solutions are ordered pairs. It's not just a single number, it's ordered pairs. So once you get one solution, you got to plug it back into either one of these. It's up to you. I'm going to pick that second one. That looks easier. So y equals 3 minus 2, y equals 1. 3 minus 2 is 1. So 3 comma 1 is my solution there. Okay? So I'm going to speed things up a little bit here. So I've got x plus 12y equals 68. Well, I'll plug in what x equals, which is 8y minus 12. So I've got 8y plus 12y is 20y minus 12 equals 68. Add 12. Now my goal is to get y by itself. So y equals 40. And now I have y by itself. Plug it back in. Well, I would want to use the one that has x by itself already. This equation has x by itself, and that's what I need. So x equals 8 times 40 minus 12. So that'd be what, 320 minus 12? Boy, something went wrong there, didn't it? 4. Good gravy. So 4. So this would be 32. So x would equal 20. I did that on purpose to show you to slow down. I wish that was the case, but I'm lying to you. Okay? Now the next guy, this is not set up for substitution. This is set up better for elimination. But let's say I have to use substitution, just to get used to it. Pick one of these variables and solve for it. So probably I mean, there's two routes you could take. I would say solve for either this y or that y. It's up to you. I'm just going to solve for this y. So that'd be y equals, bring the x over, be positive x plus 2. And now plug that in for this y right here. So it'd be 2x plus x plus 2. So 2x plus x is 3x minus 2 minus 2. So 3x equals 3. That means x equals 1. And we're not done yet because we only have half the solution. Plug this into an equation that has y by itself because I want y. So I'm going to use this equation. I'm not going to use either of those two. I'm going to use this one, which is an equivalent of the second one. So y equals 1 plus 2. Boy, that's easy. 3, so 1 comma 3. Now these last two, if you want to practice them, you can. I think I'll just put the answers down. So I got 0, 3, and 8, negative 1 for those. If you want to try those out, see if you got them right. I'm going to move on to the back side. And so the question, when should we use elimination? Remember, with substitution it was when a variable is already solved for. So when you have y by itself or x by itself. Elimination is more when it's in standard form, but even more so when one of the variables, or I should say a pair, one of the variables, the x's or the y's, the pair of x's has opposite or same coefficients. So when one of the variables has the opposite or same coefficients, if you look here, these pair of x's, same coefficient, that's good. Even better, they have opposite. The y's have opposite, so that's even better. As long as it's one of those, you can get this to work. So if you remember with elimination, since they have opposites, I can just add straight down. So I'm going to add the x's together, that's 2x. Add the y's together, that's 0. Add the coefficients together, that's 14. So that means x is 7. Boy, wasn't that easier than substitution, right? Okay, so if I plug that back in up there, if I say, 7 minus y equals 2, subtract 7, negative y equals negative 5. So y equals 5, I get 7 comma 5. Okay? If, over here I've got these are not same or opposites, that's bad. But here, these are the same, so that's good. So I can do elimination now. And what I'm going to do, instead of adding straight down, I'm going to subtract straight down. So I'm going to take 4x minus 6x, negative 2x. 2y minus 2y is 0. 4 minus 8 is negative 4. That means x is 2. Okay? And you plug that back in up there. I'm just going to, like I said, kind of save us some time. So it'd be negative 2 then when you plug it back in to either one of those. Okay? Number 3 good? Is it a good one? The y's are not opposite or same, but the w's are not, but the y's are. So I'm going to add straight down. So this would be 5w, no y's, negative 10. That means w equals negative 2. Okay, plug it back into either one of those equations, and you're going to get, let's see, negative 4. Negative 4 for the other one. So w and y. And then this guy here, now we're getting a little bit more difficult because there's neither one is the same or the opposite, but I can change a little bit. Now they are both in standard form, so that helps me. I can make them the same or make them the opposite. If I were to multiply this b by 5, it'd be the opposite of negative 5. So I'm going to do that, except I have to do everything. I'm going to multiply everything by 5. Okay, so this would be, I'll be right down here, so it'd be 15a plus 5b equals 15. And then between these two, add straight down, 17a equals 0. That means that a, divided by, now some people look at this and say, uh-oh, no solution. No, there's still an a there to solve for, divided by 17. 0 divided by 17 is 0. Okay, I'm going to plug that into the very first one. So 3 times 0 plus b equals 3. Well, that's 0, so b equals 3. Okay, so I don't know how you feel about this. Just because the video is approaching 10 minutes, I might just stop there. Some of this might be familiar. If it's not, ask questions. We can definitely still help you. I just don't want to keep the video going on and on if you remember this, because this was some hit really hard in Algebra 1. I'm sure you use it some in geometry a little bit. So it's probably ringing a bell. You probably liked elimination too. So